Okay, for this video, I'm basically going to finish up the lesson on quadratic functions that we started in Tuesday's class. And we do that by ending with what we call application problems. So up here, application problems, which basically comes down to, can you find and interpret the values of the vertex? So in the first example, you can see it says if a manufacturer of lighting fixtures has a daily production cost of this function here, where C is the total cost in dollars and X is the number of units produced. The question is, how many fixtures X should be produced each day to minimize the cost? And this is an important word here, minimize. And that is because when we try to find the minimum value of a vertex, the minimum value of a parabola, that is the vertex. In this picture here, it's the minimum. But a parabola could also open down and still has a vertex, but this vertex would be a maximum. So it doesn't matter if we're trying to find the minimum or the maximum. Either way, you're trying to find a vertex. So there were two ways to find the vertex. One way, if you had vertex form, which was very easy, you just had to look at it basically. But this isn't in vertex form, this is in standard form. So if you have a quadratic function that's in standard form, you need to make sure first that everything is in descending order. So 2, 1, constant. So yeah, everything's in descending order. So then all we have to do to find the x-coordinate of the vertex is find negative b over 2a. So if you come up here and find b, and you come up here and find a, and you just substitute those numbers in for b and a here, you'll get that x will equal 20. So as far as the vertex is concerned, x is 20. Well, x is also the number of fixtures that should be produced to minimize the cost. So 20 fixtures. The next question is, what would the minimum cost be? What would the cost be to produce that many fixtures? Well, if you're trying to find the cost based on x, you just substitute 20 in for x. So hopefully this feels a lot like what we talked about in class with finding the vertex. You find an x-coordinate, and then you find the y-coordinate by putting this into the function. So this would look like c of 20, which is 0.25 times 20 squared minus 10 times 20 plus 800. I'll put that 20 in, there we go. So what this ends up being is 100. That's if you simplify all this stuff, square the 20 first, and then multiply by 0.25. So 400 times 0.25 is 100, minus 10 times 20 is 200, plus 800 is a whopping total of $700. That's the minimum cost that will be had to make light fixtures. So let me fix this up here, fixtures. So it's important to know what your units are. In this case, x is fixtures, c of x is cost. So cost is in dollars, x is in number of fixtures. So just make sure you're keeping in line with the story here, the application. Next, in example 2, I'm going to move this up. Right about there. So example 2. I see a lot of words. A ball is being thrown into with an upward velocity of 48 feet per second. So we have a time here being seconds and a distance here being feet. So if the ball started its flight at a height of 8 feet, then its height h of t is measured in feet above ground level at time t can be determined by h of t equals this function here. So this one's slightly different. We don't have an x and a y, or we don't have an x and an f of x. What we have here is t, and that's the variable being used here. And we have h of t. So when you're trying to find the x coordinate being negative b over 2a, this worked in the previous example because x is what was in the function over here. In this example down here, example 2, we're not going to use x, we're going to use t, because that's what variable is being used here. So t will equal negative b over 2a. Well, if you just want to know what t is, you can just come back up here. T is time. So right now when we find the x coordinate or the t coordinate of the vertex, we're figuring out a time. So we just have to put 48 in for b, and it's going to be a negative 48 times 2, or over 2 times negative 16. That gives me negative 48 over negative 32, which is positive 3 over 2. If you reduce this, you can divide the top and bottom by 16, and that'll give you 3 over 2. This is in lowest terms. 3 over 2 normally doesn't make a whole lot of sense in the real world. So if you like changing this to a decimal, you can say 1.5 seconds. And that is the time it takes to reach the maximum height. The question A asks, what is the maximum height of the ball? Or how high does the ball get? So then, since we're really just finding a vertex for all of these, you're just going to take 1.5 seconds and put it in here for t, and t, and t, and just report back 44 feet. So again, if you can take the time and you just put it into the function and you crunch all these numbers down into one number, you get 44. And since h is representing a height, height is measured in distance, so it'll be 44 feet. So I'm going to move this up. You guys can try this last one. Essentially, you're just finding a vertex. I'm going to go silent here for a few seconds to give you a chance to pause the video so you can try it. So the first part of this, the variable being used here again is t. So the t in this case is time in seconds. So the t is negative b over 2a. So negative b is 80 over 2a. In this case is 2 times negative 16. This reduces to 5 over 2, and if you come down here, that tells you how long it takes to reach the maximum height. Time equals 2.5 seconds, or 5 over 2 seconds, that's fine too. Fractions are always welcome. In the real world though, people understand 2.5 seconds, or instead of 5 over 2 seconds. So it's just your preference. Let's see, so finding the maximum height, you can substitute 2.5 in for t everywhere and just know that the units are in feet. That's it. Good luck in your homework.